Hello friends, in this particular video I'm going to talk about four mathematical data structure in context to Python. These data structure I will be using to demonstrate some simple agricultural examples. Let's consider the very first type, and that is called scalar. Let's take this example. Today's temperature in Karimnagar. If I want to store that, what I will do, I'm declaring a memory representation and I'm storing the value in the form of float. This is considered as scalar type. Why? Because it does not have any dimension. So for that reason it is of zero dimension tensor. We often call these data types also in the form of tensor. So when we talk about scalar, it is of zero dimension. How about this example? I want to store the information of soil nutrient in the form of nitrogen, phosphorus and potassium. And for that reason, what I did, we made use of something called vector. Well, vector is of one dimension. Why is so? Because it has got one row. So let's consider this to be one row with multiple columns. Hence it is called a vector. In the same manner, I want to store the information about 2 years. Let's consider 2021 and 2022, where I have got 3 districts and I want to store the amount of paddy rice produced in the unit of quintal. So what I did over here, I went for a matrix. So in this matrix, I have got again an inner matrix, and that's what is considered over here as a dimension in the form of multi-dimension. Why? Because you can see it has matrix within that, it also has got a matrix. So you can think about this particular row or this particular matrix as the information of Gazwell in context to 21, that is 25 quintal, and in 22 around 27 quintal. Similarly, Medak in the year 2021 has produced 24 quintal, and in the year 2022 has produced 26 quintal of rice. And that's the representation of matrix, and that's the reason why it is called double dimension tensor. Great. And then comes something called actual tensor, which is going to hold multiple information. Let's, for example, I want to store the information of rainfall in 2 years across 3 mandals. So how do I store this? And for that reason, what I did is we made use of a tensor. And tensor, if you look over here, it's a higher dimension. The tensor is basically a higher dimension. Why is so? Because see, outside it has a matrix. Inside there is again a matrix followed by another matrix. So this matrix is going to represent the detail of the year 2023, and this one is going to represent the detail of the year 2024. So that means over here I'm going to represent 2 rows. That means consider this row in context of the month of June. Similarly, this row in regard to July for the year 2023. In the same manner, if you think about this row as June representation of rainfall for the year 2024, and this one is the July representation of the rainfall for the year 2024. And now inside this, when you pick up this one, this is the information of the month of June, right? So in this June I have got 3 different columns, and they are of 3 different mandals, or you can say district, Gazwell, Siddipet and Medak. So this is for Gazwell, this is for Siddipet, and this is for Medak. So you can understand that how a tensor is going to hold the information. Okay, so you can hold information about years, like this is the one, and individually you can hold information of month. So this is the month of June, this is the month of July, and individually you can hold information about individual mandek. Okay, so that's how the tensor comes in picture. Great. So here I'm illustrating some of the example of agriculture. It can be any case study. So this kind of representation often we will find across in our day-to-day life. All what I have said so far, I was talking about the just simple representation using Python, but I can improvise spatial libraries as well, and that brings us to something called NumPy. So whatever I have done over here, a similar thing I will do over here, but this time I'm going to use the mathematical library in context to NumPy. Now comes the question, when should I use NumPy? Well, suppose if you want to compute some average, standard deviation, mean, median, mode, inference, these are all can be done easily with the help of the mathematical library called NumPy, and which is very important. As I said over here, as you can see over here, this is a scalar representation which is of 0 dimension. This is the vector representation of 1 dimension. That means it has got one row with multiple columns. This is a matrix representation where we have got multiple matrix. So this is one matrix, this is another matrix. So this is row 1, this is row 2, and individually it has got 3 columns. And finally we have got tensor. Okay, we will see the dimension when we execute this particular program right over here with ndim. So it's a multi-dimension. So this is just an attribute that will showcase what are the shape or what are the size of this particular resources are in context to NumPy. And lastly, we come across something called TensorFlow. Well, TensorFlow is a very popular library in context to deep learning. Now, when should I use TensorFlow? Well, it comes when the prediction, probability. So if you really want to predict what is going to be the production of crop particular year, you will be using Tensor. Or if you want to identify what type of plant disease that the plant has been infected via images, you are going to use Tensor. So that means two different case studies, two different use cases are there. If you're going for just for mathematical computation, we will use NumPy, and where prediction, probability is coming in picture, we are going to use TensorFlow. That's how the beauty of Python is. And here again I have represent the data. So it is 0 dimension scalar, it is 1 dimension vector, it is multi-dimensional matrix, and it is nth dimension, and that's what tensor is all about. So now let's run this particular program and see how we are getting the output. So let me come to this particular folder, open and take a terminal, and my program has started right over here. As we can see, I am inside the environment of Python. So I am right now inside the environment of Python, and I will just fire this particular file. So Python space, the file name is called index.py, and I hit the enter to see the output. As you can see over here, the deep learning is coming in picture, TensorFlow is coming in picture. Now let's see the output. So this is the output of the scalar, a single representation. This is the output of a matrix. As you can see over here, the representation of the different chemical composition within the soil. Then comes the matrix representation of the crop production. So here is a matrix representation of crop production of a particular district, you can consider year wise. And then comes finally the beautiful stuff that is called tensor, as you can see right over here. So many information the tensor is going to provide. Here it comes. Okay, and then I'm using the same stuff in context to NumPy just to see the dimension. As I said, scalar is a 0 dimension. You can see 0 over here because of this line. It is a 1 dimension because it has got one row. For that reason, vector is 1 dimension. It has a double dimension because it has a row and column. So that brings us to matrix. And finally, tensor is of nth dimension. That's what you can see. So this is the mathematical representation of the library called NumPy. And finally, we come to TensorFlow, which is the deep learning library. And for that reason, we are here. You saw the message because TensorFlow needs the utilization of CPU. And again, you are seeing the shape. So as you saw over here, it is of 0 dimension. So that means that's the reason why you are getting a blank representation over here. Vector is a 1 dimension. So it's represented in the form of a tuple. So you can say these are all tuple representation. So vector is 1 dimension. So it has. So if you look up over here, it has got one row with 3 columns. That's the reason you can see 3 over here. And in tuple, we don't just write only 3, but we put a comma and keep an empty. That's how we represent if you have got 1 unit in the tuple. And then comes the representation of matrix, that also in the form of tuple, where there are 2 rows are there followed by 3 columns, as you can see right over here. And the last, the tensor, which is so beautiful. How about this one? Well, if you look over here, it has got 3 values. So how would you read out these 3 values? Well, the first you're going to say that how many matrix total this particular tensor content? Well, there is a total 2 matrix, 1 and 2. That's the reason why the first 2 represent the depth or the number of matrix that the tensor hold. Great. Now once you have got the number of matrix, now let's come across. So this particular matrix representation is 2 because it contains two matrices. Great. Now you come to this particular single matrix. So in this particular single matrix, so we are picking up one matrix at a time. In this particular matrix, how many rows are there? Well, exactly, this matrix contains 2 rows, so that's the reason why it's 2. So this matrix also contains 2 rows, that's the reason why it's 2. Now you pick up the first matrix, how many columns are there? Well, this particular matrix has got only 2 columns, that's the reason why it is 2. So first you counted how many matrices are there, then you counted a particular matrix, how many rows are there, and then you counted that particular matrix, how many columns are there. And that's how this output has been framed. So in this particular video, I tried to show you that if you have to hold information of different statistical data, how Python will be effectively used and how these libraries are going to do amazing work. Okay, so that's all from this video presentation. See you soon. Bye bye.